Hey, Math 098, we're going to do Chapter 8, Section 1, and we'll be solving quadratic equations by completing the square. And the first thing they want you to do is just practice the square root property. And what the square root property is getting you to practice is if you have a square problem, you square root both sides. And I believe they want you to do two things. The first is that we have a plus or minus, because remember, if you take a negative value and you square it, you'll get a positive, in this case 50. And then also practicing the simplest radical form. We do like simplest radical form, and I like to explain that by factor trees. So like 25 times 2 will give me 50, and then 5 times 5. And I like to circle pairs of numbers, so then we can write the pair outside the radical, 5 root 2. So what I'm saying is 5 root 2 is the same thing as the square root of 50. Now, if you are going to round, let me clear this out, and you hit in your calculator the square root of 50, just round to 3 decimal places, 7.071. And you can see that my answer is correct, the 5 times root 2, because I'll get the same exact decimal between the two of them. So I'm going to walk you through simplest radical form. I'd prefer to see that, but if the back of the book has 3 decimals, I can work with you on that. So what's different about this second example here, let's change colors, is you need the x squared by itself first. You see how that was already by itself here. So what you would have to do is add 14 over, and then divide by 2 to cancel those terms out. So you're left with x squared is equal to 7. And then from there, square root. And don't forget to write plus or minus. We have a positive or a negative square root of 7. That's what I'm looking for. Which is pretty important before we get to completing the square, that you understand that square root property, because that'll actually make the next part a little bit easier. So what you notice in this problem is that the square is already by itself. So they're methodically getting you to understand this problem. So once you have the square all by itself, which it is here, we can square root both sides, and the square and the square root will cancel each other out. You're just left with x plus 3. And I do want you to practice that factor tree, 4 and 5, and then 2 and 2. We have a pair of 2's, so the square root of 20 is equal to plus or minus 2 root 5. And again, you can use a calculator to check your work. Square root of 20, is that really equal to 2 root 5? And I get the same decimal, so it's correct. And then from here, the way I want you to write your answer, well, since it's addition, to move a 3 to the other side is to subtract 3 over. And we like to write that term in front of the plus or minus 2 root 5. This is just a mathematical preference that a lot of math teachers will do. Now, what does this actually mean as far as decimals go? Because I know a lot of students don't understand what this actually means. Is that you have 2 different answers for x. And those 2 answers in decimal form would be negative 3 plus 2 root 5. So about that answer. And then negative 3 minus 2 root 5. So these are your 2 decimal approximations, which I don't want you to write down. I'm just trying to get you to understand what that actually means. And I can actually show you with a graph as well how to determine those are the correct answers. If I go back to y equals, and let me clear this out, this is a different class, and I were to just type in those 2 equations, so x plus 3 squared, and in a second equation, y equals 20. Now, when I hit zoom 6 to get my standard window, I don't know if you guys are using the same calculator. Right now, you only see the parabola. And the reason why you only see the parabola is the y equals problem is all the way up to 20. So that's where you would change your window to say, oh, well, let's make my y value go up to, I don't know, 25. Go back to my graph. And now we can actually see the two lines intersect each other. Well, where do they intersect? Well, let's hit second trace. The fifth option down is a point of intersection. And this is part of the reason why I don't like a graphing calculator. Like Desmos, I can just click on the graph and see what the answer is. But this one, I have to do all of these buttons. Then I have to hit enter 3 times to say, hey, I want the blue line and the red line. Hit enter. And then I have to guess where that answer is. So hit enter a third time. And the point of intersection was 1.472. Well, where did that answer come from? If I go back to the home screen, 1.472. So what we're doing is we're finding out how, where these two curves intersect, the values of x that make that equation true. And I forgot what the other one was, like negative 7.472. And just to show you one more thing, I'm not trying to waste time here. I truly want you to understand. If I go back to second trace, point of intersection, well, now if I move my cursor to the left, because your calculator can only find one point of intersection at a time, hit enter 3 times there, there's my other answer. Now we ignore the y equals 20 because, well, that's saying that we want this side to equal 20 and this side to equal 20. That's why I don't really care about this y value. I only care about the x values. So I'm actually going to use a graphing calculator to explain this one right here. So I'm going to go back to my equation. It was 5x minus 2 squared, and then the other answer was negative 9. So if you were to think about this kind of intelligently, and well, I'll just hit zoom 6 to go back to my standard window. That's what that's for. You should see we have an upwards parabola and then a horizontal line way down here. So my question to you is, where do they intersect? And I hope all of you are thinking it. Obviously, we can't interact on a video. That there's no point of intersection, so there's no values for x that make this true. So this one is no solution. Or you can do your circle with a slash through it. And the reason for that is, can you think of any number when you square it will give you a negative? And a quick answer is any number. So I don't care what these numbers are, positive, negative. Once you square it, I'll just write y because I want a different variable than x. The quantity of 5x minus 2 squared is always a value that's at least 0. It's never equal to negative 9. So it can never equal a negative. And the real shortcut is seeing that when you square root both sides, okay, if you were to try this on a calculator, it would say domain error. So there's no solution. All right, so be ready for that in this homework assignment. And let's see, there's a lot of examples of this completing the square, which I believe you guys did in Algebra 2. Notice the directions say to check graphically, which I already walked you through how to do that. And there's a lot of steps to this. So feel free to write down any questions that you may have and bring them to class or email me and we could set up a Google Meet. And you can see there's a lot of exercise before we get to the homework. And I'm not going to rush through this. So stick with me. I'm going to start at the beginning. The first thing that I do is I'm going to separate things. So all I'm doing is giving myself some room. All right, maybe I'll put a little line here because that's my next exercise. And so the process, so let me change colors, is I take this number, the number that's attached to the non-squared term, and I cut that in half. And then what I need to do is I need to square that number. So 4 divided by 2 is 2. And once I square it, I get 4. So this number is what's going to be put right here. Now here's the thing, is we cannot just randomly throw in a +4 into a problem. We can only throw that in is if later we put in a +4. So whatever you do to the left side of an equation, you also have to do to the right side of the equation. Now, why on earth would anybody do that? Well, now what we have on this, by going through that process, is we can factor the left side. And what are factors of 4 that add to be 4? 2 and 2. Now, instead of writing 2 and 2 twice, we can write b plus 2 squared. And on the right side, we can just add that together. It's equal to 7. 3 plus 4 is 7. So if I go back a slide, that looks just like these problems. We had something plus something, or something minus something squared equals a number. Because you could get a negative over here, but in this case we do get a positive. So now we can go through that process of, okay, well, we're going to square root. Well, I can't break down 7, so let's leave that as plus or minus square root of 7. Notice the square root and the square cancels. So my answer, and this is how I want you to write it, is subtracting the 2 over plus or minus root 7. Now checking this work, checking graphically, you can't, this is why I want your answer like this and not as a decimal, is because if you go to a graphing calculator, again, I'm going to show you my graphing calculator, and just type in the original problem. Now, I'm not going to type in b, I'm going to type in x, squared plus 4x. And the second equation is equal to 3. I'm just double checking that I typed it in correctly. And when I go to my graph, I think it's good if I just look at that. I have 2 points of intersection. If I hit second trace, the 5th option down, I can find my point of intersection right here. Enter, enter, enter. And where does 0.646 come from? Because some students will just write that down and expect full credit. Well, that's not completing the square. Completing the square is the work that I did here. Well, if I go back to my home screen and type in -2 plus the square root of 7, you get the correct answer. And I'm going to trust that you can check the other one is -4.646 to check your work. So if I go back to my graph, second trace, the 5th option, move my cursor over, hit enter thrice. There's a Shakespeare word for you, -4.646. So I was correct. And you can do every problem like this, okay? So I think I'm going to wait to do the next 3 in a second video. One more thing before I end this video, though, is the process I showed you had a leading coefficient in this problem of 1. That's going to be important as we get to the next video. So stay tuned for that. I'll show you what to do if your leading coefficient is not 1. All right, and we'll see you there.